Saturn is easily the most recognizable planet in our solar system, and some of its moons are the most famous too. Titan, Enceladus, and Rhea all move like clockwork in an elegant dance around this ringed giant. But out in the far reaches of Saturn's gravitational influence, millions of kilometers from the planet, prowls an object that does not belong. It is dark, scarred, and solitary. It moves backwards, crashing against the flow of the rest of the system. It is a time capsule from an era when the giant planets migrated and the solar system tore itself apart. This is a world of landslides, of frozen carbon dioxide, and a hidden ring of dust so massive it dwarfs Saturn itself. It is a moon that shouldn't be there, a visitor snatched by Saturn's gravity and held prisoner for 4 billion years. This is Phoebe. I'm Alex McColgan, and you're watching Astrum. Join me today as we journey to the edge of Saturn's domain to unravel the secrets of its darkest, most mysterious moon. The story of Phoebe begins with a quiet revolution. For thousands of years, astronomy was limited by what is possible to see with the human eye. First astronomers used the naked eye, and then in the early 1600s, the invention of the telescope revolutionized what it was possible to see. But it wasn't until the 19th century that the dry plate photographic revolution changed everything. For the first time, astronomers could leave a camera shutter open for hours, allowing light to accumulate on glass plates, revealing objects thousands of times fainter than what Galileo or Cassini could have ever dreamed of observing themselves. In 1898, a team from the Harvard College Observatory, led by William Henry Pickering, set up an outpost in the thin, dry air of Arequipa, Peru. Using the 24-inch Bruce telescope, they began a deep photographic survey of the southern sky. The work was tedious. The glass plates were shipped back to Cambridge, Massachusetts, where they were pored over by computers, human analysts using magnifying loupes to spot new objects on the plates. Then, in 1899, Pickering was examining plates taken the previous August when he found a speck. It was faint, magnitude 15.5, roughly 4,000 times fainter than the limit of the naked eye. But what was most fascinating about this object was that it moved. Pickering traced its path across multiple nights. The stars stayed fixed. Saturn moved, but this speck moved with Saturn, yet not like the other moons we already knew of. On the 18th of March 1899, he announced the discovery of Phoebe. It was a landmark moment, the first natural satellite in history to be discovered not by direct observation, but by an image on a photographic plate. As astronomers tracked Phoebe in the early 20th century, the excitement of discovery turned into confusion. Phoebe wasn't just far away, it was wrong. The solar system has rules. Because everything formed from the same spinning disk of gas, the planets and their moons almost universally spin and orbit in the same direction, counterclockwise or prograde. Phoebe breaks this law. It orbits Saturn clockwise, in the opposite direction to the planet's rotation and the other moons. This is known as a retrograde orbit. Now, when we find a moon orbiting backwards, we know one thing with absolute certainty: it did not form there. If Phoebe had formed from the dust surrounding the infant Saturn, the drag from the gas cloud would have forced it into a prograde orbit. A retrograde orbit is a smoking gun, pointing to a very violent history. It means Phoebe is an immigrant, a captured object that formed elsewhere, and was ensnared by Saturn's gravity. And the distance of this moon is staggering. Phoebe orbits at a mean distance of nearly 13 million kilometers from Saturn. That is nearly 4 times further out than Iapetus, and almost a quarter of the distance from the Sun to Mercury. It takes 550 days, about 18 months, for Phoebe to complete a single lonely lap around the ring planet. It's so far out that, from the surface of Phoebe, you would not be able to see the rings of Saturn with the naked eye. All you would see is the glare of a tiny but bright planet in the night sky. Because it is so far from its host planet, Phoebe went uninvestigated for nearly a century. Even Voyager 2, which flew through the system in 1981, only saw it as a jagged, dark blob from 2.2 million kilometers away. We knew it was there. We knew it was weird, but we didn't know what it was. That changed with Cassini. When mission planners were designing the trajectory for the Cassini spacecraft, they realized they had a unique problem. To enter orbit around Saturn, Cassini had to brake. This meant approaching the planet from the outside in. They realized that, on this arrival leg, before the critical engine burn that would trap the probe in Saturn's gravity, they could pass by Phoebe. It was a one-shot chance to get a close-up look at this elusive moon. The encounter had to happen on the 11th of June 2004, 19 days before orbital insertion, because once Cassini fired its engines and settled into the inner system, that was it. It would never have the fuel to go back to Phoebe or match its backward speed. For a few frantic hours, the dark moon filled the cameras, transforming from a dot into a complex world. The relative velocity of the flyby was a staggering 5.8 kilometers per second. And then, Phoebe was gone, receding into the darkness. It's incredible to think how much work and planning went into a flyby like this. Hundreds, if not thousands of scientists planned and prepped for quite literally decades to make this happen. Now, I'm not quite comparing making an Astrum video to launching a probe halfway across the solar system, but they do take a lot of work to create. And without our amazing group of astronauts over on Patreon, we wouldn't be able to make as many as we do. If you want to be a part of this community that helps keep Astrum running, and not to mention get the chance to watch all our videos not only early but completely ad-free, then scan this QR code or click the link. You can even get a personal shout out from me, or have your name added to the rockets at the end of our videos. Hopefully that's at least nearly as exciting as these pictures of Phoebe. The images Cassini beamed back revealed a world that looked nothing like its siblings. Phoebe is roughly spherical, about 213 kilometers across, but it looks absolutely beaten. It is dark, with an albedo of just 10%, making it as black as asphalt. Cassini's cameras mapped the surface in detail, revealing the crater saturation and brightness variations. Spectrometers analyzed the surface composition, detecting water ice, carbon dioxide, iron-bearing minerals, and signatures consistent with primitive carbonaceous materials found in meteorites expected in outer solar system bodies. Dominating the surface is the Jason crater, a massive impact basin 101 kilometers wide, nearly half the diameter of the moon itself. The fact that Phoebe survived such a hit is not only astonishing, it tells us it is a solid body and not a loose pile of rubble like some asteroids we've been visiting. But the most striking features were the landslides. Gravity on Phoebe is weak, but strong enough that when meteorites strike, they destabilize the crater walls. Cassini saw bright, white streaks where the dark surface material had slumped away. Phoebe isn't a rock, it's a dirty ice ball. It is an ice-rich body coated in a thin veneer of dark dust, perhaps only a few hundred meters thick. The true nature of Phoebe was hidden in its density. By measuring how much the moon tugged on Cassini during the flyby, scientists calculated its density to be about 1.63 grams per centimeter cube. This is the key. Saturn's regular moons are mostly pure, porous ice, about 1 gram per cubic centimeter. Phoebe is much denser, implying it is around 53 to 67% rock. This density is similar to Pluto and Triton. It suggests that Phoebe is a planetary embryo, a world that started to differentiate, separating into a rocky core and an icy mantle, but was stopped sometime in its development. The chemical fingerprint confirmed it. Cassini spectrometers detected carbon dioxide trapped in the surface rocks. On the inner moons, volatile CO2 would have boiled away eons ago. Its presence here confirms that Phoebe formed in the deep freeze of the outer solar system, far beyond the orbit of Neptune, a survivor from the Kuiper Belt that found its way to Saturn and got caught up in its gravitational pull. And Phoebe's story doesn't end with its capture. For billions of years, this dark moon has been subjected to a relentless rain of micrometeoroids. Every tiny impact blasts a little bit of that dark surface material into space. Because Phoebe's gravity is so weak, this dust escapes easily, entering a retrograde orbit around Saturn. Over billions of years, this dust has accumulated into a structure that remained hidden from humanity until 2009. Using the Spitzer Space Telescope, astronomers discovered the Phoebe Ring. And it is enormous. This ring is invisible to the naked eye, but in infrared, it glows. It spans from 6 million to 16 million kilometers from the planet. You could fit roughly 1 billion Earths within its volume, and if you could see it from Earth, it would be the width of 2 full moons in our sky. It is the largest ring in the solar system, and Phoebe orbits right in its heart. But the dust particles within it are spread extraordinarily thin, making it virtually invisible in reflected sunlight. Spitzer could only detect it by sensing the faint thermal glow emitted by the sparse dust grains themselves. Crucially, this gigantic ring is tilted by 27 degrees relative to Saturn's main flat ring plane, perfectly matching the inclination of Phoebe's own orbit. It also shares Phoebe's retrograde motion. The ring's composition, inferred from its infrared signature, is consistent with the dark, primitive material making up Phoebe's surface. The source was confirmed. Micrometeoroid impacts on Phoebe are in fact generating this vast, diffuse halo of dust. This discovery solved one of the oldest mysteries in astronomy. In 1671, Giovanni Cassini discovered the moon Iapetus and noticed it had a yin-yang appearance, one hemisphere as white as snow, the other black as coal. Well, now we know. Phoebe orbits retrograde or clockwise, while Iapetus orbits prograde or counterclockwise. As the dark dust from the Phoebe ring spirals inward towards the planet, it slams head-on into the leading face of Iapetus. Phoebe is effectively spray painting its neighbor from millions of kilometers away, like an interstellar Banksy, creating the stark contrast that puzzled astronomers for 300 years. But how did this dark, dusty moon, born far beyond Neptune, end up at Saturn, so much closer to the Sun? The leading theory, known as the Nice model, suggests that 4 billion years ago, the giant planets migrated, violently disrupting the primordial Kuiper Belt. In that gravitational chaos, countless icy bodies were thrown into the Sun or ejected into interstellar space. But a lucky few, like Triton and Phoebe, were captured and became moons. Phoebe, then, is more than just a moon. It's a relic. It is a surviving piece of the building blocks that formed the outer solar system, preserved in the deep freeze of Saturn's gravity. It tells us of a time when the planets moved, flinging rocks around the solar system to be captured by the huge gas giants that dominated. And while we've learned much, questions remain. What lies beneath the dark surface layer? Does it have a differentiated internal structure, perhaps a rocky core surrounded by an icy mantle? Can we definitively pinpoint its origin region within the Kuiper Belt or scattered disk? Phoebe remains an object of intense interest, a primordial messenger holding clues to the materials, processes, and dynamics that governed the early solar system. It's a reminder that planetary systems are not static, but dynamic places where objects can wander, be captured, and leave their imprint far from where they originated. Phoebe, the dark intruder, continues to orbit Saturn, a lonely sentinel that has left a permanent mark on the Saturn system. There's a reason these educational mini-documentaries are free for everyone. It's not just the ads or sponsors, but it's thanks to our hundreds of Patreon members who make it possible for everyone to get the best possible content. They are the foundation that keeps Astrum steady and focused on quality over clicks. Every video you watch exists because there's a community behind it that values learning and curiosity. If you'd like to be part of that group, the people who keep space education open to everyone, join us on Patreon through the link below. We would love to have you.